Okay, we're continuing on with part 3 of chapter 11, Conceptual Physics, on the atomic nature of matter. We're going to talk about ions and isotopes. Let me dismiss my image. An ion is a charged atom. Positive ion has a deficiency of electrons, such as the sodium, which might lose an electron. A negative ion has an excess of electrons, such as the chlorine, which can take on an electron. An isotope is an atom of the same element with a different number of neutrons. Isotopes exhibit mostly identical behavior. Some of the uranium, some of the uranium isotopes, they react differently because of their radioactivity. Some very stable, some are more radioactive than the other. That's why certain countries, not to be mentioned, or try to separate the uranium into their more radioactive parts for making nuclear fuel, and if they can make enough of it, they can make a nuclear bomb. Anyway, we'll not get into politics, but let's continue. The number of protons in the nucleus matches the number of electrons surrounding the nucleus, but the number of neutrons may vary. Isotopes, the atoms of the same element with different numbers of neutrons. The mostly identical behavior identified by their mass number, the total number of nucleons, that's protons plus neutrons. An example is an iron isotope with 26 protons and 30 neutrons, has a mass number of 56, referred to as iron 56. Okay. The atomic number of an element matches the number of protons in the nucleus of an atom, electrons in a neutral atom, both of the above, or none of the above. Now, the fact that it says in a neutral atom, electrons in a neutral atom, that means that both of these are above. If the atom is neutral, that means it has as many electrons as it has protons. So both of these are true. If it just said electrons in an atom, that could be false because you can very easily lose an electron. So let's look at the answer. Both of the above. When the atomic number doesn't match the number of electrons, the atom is an ion. Okay, let's see. A nucleus with an atomic number of 44 and a mass number of 100 must have 44 neutrons, 56 neutrons, 88 neutrons, or 100 neutrons. Well, the sum of them, the sum of the protons and the neutrons has to equal 100. So in this case, it would be B. And there it is. The number of neutrons is the difference of the mass number and the atomic number. This is ruthenium 100, which it has 44 protons, hence the atomic number, and 56 neutrons, since 44 plus 56 equals 100. Okay, and that's a short one. That's the end of part 3. We'll stop it right there.